Assalamu alaikum wa rahmatullah, and a very good afternoon to all of you, our respected viewers and not listeners to Voice of the Cape. Alhamdulillah, it gives me great honor and pleasure to introduce myself. My name is Amir Adams, and I am a presenter here at VOC. And Alhamdulillah, it gives me great honor and privilege to be on this Facebook platform of Voice of the Cape, where I have the privilege of introducing our guest. This basically is a Facebook Live platform that we have dedicated to all of you, our beloved listeners, and more so all the matriculant students out there who are preparing for the upcoming examinations. Of course, we have now the trial examination period, or it's known locally as the mock exams, and thereafter everyone, the matriculants, will be preparing for the NSC exams, inshallah ta'ala. For the time being, today we have our first session where we are honored to be engaging with Sister Alia Kara, and she is from the Futures Academy SA online high school platform. Today, the session is dedicated to geography, engage in this beautiful platform where you will be able to prepare for your matric geography paper 1. So today, I officially hand over to Sister Alia Kara, who will be conducting session 1, and this is entitled Geography Preparation for Paper 1, and in particular, we will be dealing with strategies for climatology. Without further ado, we hand over to Sister Alia Kara to conduct the revision for all of you, our matriculants. Bismillah.
Assalamu alaikum wa rahmatullahi wa barakatuh. Shukran so much, Brother Amin. I hope you're all well, and let's continue. Uh, Today I'm just looking at the first section of our climatology section, which is the mid latitude cyclone. Now, before I do that, I just want to break it down for you in terms of the type of questions that we can actually get for our paper one. So, it is firstly broken up into three different questions. Question one being climate and weather, question two, which is geomorphology, and question three, which is map work, not only skills application as well as GIS. Now, the way it actually is broken down further is we get three different types of climate questions, and we get short questions, which is generally a 7-mark question and an 8-mark question consisting of climatology. Perhaps here we have our definitions, we have our metric column A with column B, underline the correct word, fill in the correct word. Those type of questions would come into your short questions. Your three main questions generally are broken down into a 1 mark, then 2 marks, three, then perhaps six or eight, just depending on the type of question that you are getting. Question two follows the exact same way that question one follows. And lastly is your map work section. Remember, your map skills and application is only out of 10 marks. Your application and interpretation is out of 12 marks. And your GIS section is out of 8 marks. Please bear in mind, you have one paragraph question in both question 1 and 2. That means a 4 times 2 equals 8 question that you would have to answer with regards to a paragraph question. Also, remember that your definitions generally is a 2-mark uh, sort of scoring. Anyway, the new type of structure that they have brought in with regards to climatology as well as geomorphology is this type of question that you see in front of you, where they provide you with 4 different words or sentences or phrases, and it is a multiple choice question which includes both of these two of the answers from the above. So, for example, this one here says the interior South Africa experiences something conditions with a greater temperature variation due to something climatic conditions. So your answer would be unstable. So it will be the first one. And maritime, meaning ocean temperature or ocean climates. And that would be 4. So your answer would then be 1 and 4. So this is the type of questioning that they have sort of introduced into the actual system for us. Now, let's break down first climatology, and then from there, we'll go on to questions that are based on your mid-latitude cyclone. What you see in front of you is the only thing that you require for climatology, which is your mid-latitude cyclone. The first thing that you would need to know is what the mid-latitude cyclone actually looks like. So if you have a look at the diagram, you'll see that there is a low pressure system that sits in the ocean, which is the Atlantic Ocean. It has a cold front and it has a warm front. You need to be able to recognize which one is the cold front and which one is the warm front. You would also need to know what is an occluded front. So an occluded front is where you find the warm front and the cold front coming together. Please bear in mind, with a mid-latitude cyclone, our rotation of the actual cell is in a clockwise direction, and it has circular isobars with the center or the pressure in the center being below 1,000 millibars. In this particular case here, back into the first little diagram, you will notice that there is 2 mid-latitude cyclones. Remember, a mid-latitude cyclone only occurs in families of 3 or 4. So in this case here, this would be the first one where the occluded front is, the second one which is approaching the interior South Africa, and the last one which is on the far bouts, it's in its developing stages. All right, now the different types of weather patterns that are associated with a mid-latitude cyclone, please bear in mind, you only need to know the following. The type of temperature that you would get with a cold front and a warm front. So let's go with the cold front first. Temperature drops when a cold front approaches the interior South Africa. With regards to a warm front, you will receive a sudden rise in air temperature itself. Your air pressure in a cold front will increase, but in a warm front, it will decrease. Then the most important thing that we need to remember with a mid-latitude cyclone is something called wind backing. So the wind will change from a northwesterly direction to a southwesterly direction. Sorry, there's a bit of an errata here, where it's the cloud cover is thick and rainfall is extremely heavy. With the warm front, the wind will change from a northeasterly direction to a northerly direction. So there's no backing of wind with a warm front. Your cloud cover will not be thick. It will be significantly low, and your rainfall stops completely. Now, the type of conditions that are associated with your mid-latitude cyclone is that we need 2 high-pressure systems, which is our tropical high pressure. So I don't know if you can actually see this, but if you have a look on here, in the center of this little diagram, you will see it says the subtropical high pressure belt, and you get the polar high pressure belt, which is found near the polar regions. Remember, the subtropical makes up your warm air, Your polar makes up your cold air. When two masses meet, they form a front, and that front then helps to develop the mid-latitude cyclone. Now, you can't really see the actual stages in this particular diagram, so I'm just going to go all the way past here and into the question section where you can see it quite well. You get 4 different stages of your mid-latitude cyclone. The initial stage is the beginning. Remember, I said to you the cold air, the warm air. Where they meet is a front, and this is where our mid-latitude cyclone begins. Then you get the development stages where you see the low pressure cell developing, as well as the cold front now starting to appear. The warm air gets pushed away because why? Cold, dense air starts to move very quickly down. And so it starts to catch up with this particular warm front. Eventually, I'm in a mature stage, and the mature stage presents 3 different sections. The middle section is what we call the warm sector. A warm sector is generally found behind a warm front. Then we get something called the cold sector, which is found behind the cold front. The mature stage of the mid-latitude cyclone is generally tested the most, and 2, it's the most extensive. And then last but not least, this is when the system starts to diminish, and it is called the occluded front. Here is where we find your tail of your cold front and your warm front that join together. Your warm sector is very short and small, whereas your cold sector is quite large. Right, so we're going to go back again. The type of cloud that is associated with your warm front is generally a nimbostratus type of cloud. So whenever you have a warm front that is approaching the interior of South Africa or is already in the interior of South Africa, you will find this very steady, consistent type of rain that's not heavy. And that comes from the nimbus stratus. And it's not only over one particular area, but it's over a vast area. So that steady rainfall that we get throughout the day or for hours perhaps would come in with nimbus stratus. The cold front, however, develops completely different. The cold front, because it's wedging its way underneath the warm air, it forms this very steep type of gradient. And this steep gradient gives rise to cumulonimbus clouds. And those clouds are very heavy in terms of rainfall. So a very heavy lightning storm would actually take place, but over a very short or a very small section. One of the other things that we need to know is our cross section of our mid-latitude cyclone within the mature stage of its development. So here you can see very clearly that steep gradient that I was talking about with the cold front. And with the warm front, it is not a steep front. It is very gradual. The cumulonimbus clouds, which develop on this particular front, and that heavy rain that is associated with it. Remember, behind the cold front is your cold sector. Your warm front, behind the warm front is your warm sector. And then last but not least, in terms of what strategies can there be in order to minimize the effect of a mid-latitude cyclone, is where you develop a monitoring system of the mid-latitude cyclone, present early warning signals to indicate that there is going to be an approaching storm that is coming into, and we know that the mid-latitude cyclone only affects the southwestern Cape. in particular. So you would have warning signals for that. People could evacuate low-lying areas to protect them from flooding. We could keep livestock in barns to protect them against the cold and plant winter crops that can resist cold. Remember, I forgot to mention this in the beginning, but you should have known this, is that a mid-latitude cyclone only appears or only comes towards our interior South Africa in the winter months of the year. So remember, point number one, it is a low pressure system. It circulates in a clockwise direction. Its movement is from your west going towards your east. It develops only in the winter months of the year. It has a very distinct warm front and cold front. Right? Now, what do we need to know with regards to the mid-latitude cyclone? We need to be able to identify the cold, warm, occlusion fronts. That's the first thing. We need to also be able to recognize the type of wind direction. Remember, the wind backs. Next, we need to know cloud cover. So, with the cold front, we will have full cloud cover where our dew point temperature is very, very similar to our air temperature. The type of clouds, remember there's two types. Your cumulonimbus clouds is with your cold front. Nimbostratus is with your warm front. And the stages of formation. So remember the 4 different stages of formation. You need to name the general direction of the movement. So you would say it moves from the west going towards the east. And the reason for this is because it is traveling in the westerly belt. Define the warm front and the cold front and describe where and why it forms there. You also need to state the different stages in the weather that is caused by the cold front. So remember that first diagram that I showed you with a little block? That's the one that we need to actually know. You need to also be able to label across a section of not only the cold, warm, and occluded front. Describe the impacts that could be associated with the mid-latitude cyclone and suggest strategies. So let's take a look at the different types of questions that can be asked by us. So this was actually a kit that was put together by the various departments, not only WCED, but also the GDE, where they have given us an indication of the type of questions that can be asked with regards to our mid-latitude cyclone. So the first thing that we look at is name the general characteristics of a mid-latitude cyclone. Remember the cold front, the warm front, the circular isobars, then the occluded front, the cold sector, the warm sector. The pressure that is below 1,000 in the center, and that the isobars drop going towards the center. So remember, they decrease in pressure. Also, that it moves from west to east. You can also place in another one here where we could say that the wind backs from a northwesterly to a southwesterly wind. The next question that could be asked is, what weather changes occur when a cold front moves over an area? So what weather? Remember, the question is asking you what weather. So when we talk about weather, we are talking about wind, cloud, rain, humidity, temperature, all of that. That's what we're referring to. So weather is immediate, something that you can see outside. Climate is a different terminology. Don't confuse the two. So what we would say is that we would get a sudden decrease in temperature, the air pressure increases. We could also say the wind direction changes from a northwest to a southwest. The wind speeds are extremely high. It is almost close to a gale force wind. The cloud cover is very thick with cumulonimbus and cumulus clouds. Rainfall, heavy showers, and humidity decreases significantly. Please remember, they could also ask you this type of a question on a synoptic weather map, where you would have to look at the map and see what you can see on the map. So remember, when you are looking at an actual synoptic weather chart, the first thing that you are going to identify is the following. I'm just going to go back into our synoptic weather map that's on this previous page. Your cold front is the first thing that you're going to pick up. Your warm front is the second thing you're going to pick up. The next thing you're going to pick up is your isobars, which are circular, and your wind. So if you have a look at your weather stations, you will find that it has full cloud cover. In this particular case, it is almost 35 knots of wind speed, and the direction of wind is what in this particular case? It is southwesterly already. So we can see that. Right. Another very interesting question that we've noticed that they've been asking is distinguish between a warm front and a cold front. Remember, point number one, the warm air is forced to override cold air. So the gradient of your warm front is not as steep. Now, the other significant part of it, nimbostratus and altostratus clouds develop with it. In terms of the cold front, we'll notice the steep gradient, we'll notice the steep gradient of the cold front with cumulonimbus clouds that develop with it. Remember, cold air undercuts a body of warm air. So essentially what it's saying to you is that the cold air wedges itself underneath the warm air and it drives the warm air away. So that's the next important thing that you need to know. Next one, identify the stages of the mid-latitude cyclone, and you need to give a reason for your answer. So you would need to know what each stage looks like. So remember, in the initial stage, it was where your cold air was moving from your east to west and your warm air was moving from west to east. That was your initial stage. Your development, the beginnings of a low pressure cell. Mature stage, very clear defined cold front, warm sector, cold sector, and pressure begins to decrease in your center of your cell. Your occluded, remember the tail is the perfect giveaway for your occluded, and the warm sector, which is extremely narrow. They can also ask you to draw a cross-section of the mid-latitude cyclone. So remember, when we draw the cross-section of the mid-latitude cyclone, it is this diagram here that you would actually see. So this diagram is a very important diagram. Remember, the cold front is steep. Your warm front is not. Your cumulonimbus clouds, you'll get 1 mark for that. You'll get 1 mark to indicate the actual front itself. You would get another mark to indicate your warm front, and you would then get the general directions. Please do not forget to add them in. The way this type of question could be asked is in 2 ways. It could either be a full-on 15-mark question, or it could be your 8 or 7-mark question. depending on obviously the examiner at that particular point. It's imperative that you know both the cyclones. So you need to know the mid-latitude cyclone and you need to know the tropical cyclone. Remember, the tropical cyclone develops in your summer months of your year, but it is also a low pressure system. Your mid-latitude cyclone, winter months of your year, also low pressure system. Also, bear in mind one final thing before I conclude today is a low pressure system brings about rainfall. A high pressure system brings about stability. So there is no rainfall with a high pressure system. And the three high pressure systems that we find in South Africa is your Kalahari High, South Indian High, and South Atlantic High. So join me again next week where we will go through tropical cyclone, questions associated with it, including, I was going to actually do map work today, but time does not permit it. So I will do the map work with you next week, inshallah. Back to you, Brother Amin.
We say shukran, jazakallah khair, and in Cape Town we typically say pai terima kasih in the language of our forefathers. Thank you very much to Sister Alia Kara of the Futures Academy SA Online High School for so beautifully conducting the first session, and that was geography and pertaining to strategies for climatology, paper one. We hope that all of you, our beloved viewers, have enjoyed this session. And please, this link will indeed be on the Facebook page as well as the YouTube platform of VOC. Send the link, forward the link to all of the matriculant students out there who do geography, who are in need of this. And I hope that this will be of great benefit to all of the students out there. Once again, we'd like to say thank you very much to Alia Carter for conducting the first session on behalf of Futures Academy SA Online High School. We thank her very much. Until we pick up tomorrow for session 2, inshallah, we wish you all the very best. Wassalamu alaikum wa rahmatullah.